This podcast is supported by Siemens, your partner for industrial-grade AI.
Hello everybody and welcome to a new episode of our Industrial AI podcast. My name is Robert Weber and my guest today is Dr. Jan Koutnik. Hello Jan, welcome to the podcast.
Hello, how are you?
I'm fine, thank you. Many people remember you from your time at NNAISENSE. We first met at Festo, that was about reinforcement learning and self-organizing factories. Today you are in a new role and you have, from my point of view, changed sides a bit from technology development to integration as a partner to industrial companies. But please introduce yourself briefly to the listeners, Jan.
Okay, so my name is Jan Koutnik.
Koutnik, sorry.
The original name is Koutnik, but that's the Czech pronunciation. So I always say Koutnik because that's how non-Czechs read that.
Okay.
I checked out in 2009 and I left that, mountain surrounded country and went to the mountain country, Switzerland, to join ITSIA, the Swiss AI lab, working with Professor Jürgen Schmidhuber. And then we founded NNAISENSE in 2014. It was a couple of reasons for that, because we were getting industrial demands for proof of concepts, which we wanted to satisfy. And we were not able to do that as quick at the university environment. The other drop was that was a time when DeepMind was sold to Google, and DeepMind was co-founded by Shane Leck, who was one of the ITSIA graduates. And Jürgen always wanted to have his own AI company. So we surrounded him. It was 5 founders at the time we founded the company. And the first deal we had was in finance, which sort of helped to bootstrap it such that we didn't really have to get the seed round. Then we went through a couple of funding rounds. We had a couple of notable clients like Audi, for example, Festo that you mentioned, Trump, and so on. And then the COVID came and the company sort of went down, and now it's reoriented to just fintech. So I got flushed out, and I'm still in the field of intelligent automation. At the company, I was the only intelligent director because my title was Intelligent Director of Automation. Now, the Director of Intelligent Automation, and my group was responsible for all the sort of reinforcement learning and evolutionary computation projects with industries. So I didn't do much of the deep learning at the time, but we collaborated with my fellow Jonathan, and we were using deep learning, obviously, in all our projects. So that was the time when, the deep learning was going through the boom, and it was before the generative models had their boom, which we are sort of going through now.
And you established your own company, right?
So right now, I'm affiliated with a company that I will soon become part of, hopefully. Because after, I got out from NNAISENSE, I had that year period of when I couldn't, really compete and work in the same field in Switzerland as NNAISENSE was. But that has expired now, and I'm free man. I can do whatever I like. So I'm working with one of my former colleagues from Czech Technical and also NNAISENSE, and one of my former classmate who's very good salesperson now. So we are putting together a company which should stand on that ground of intelligent automation. The company is sort of like an integrator, but it should not be like what NNAISENSE was. And we basically want to take it from a different perspective, because at NNAISENSE, NNAISENSE was more understood like a consultation company. And we were doing a lot of proof of concepts for mostly German companies when they came and they had some AI problem and said, like, guys, can you help us with that? And we were, I would say, very good and very successful at estimating how much effort it would take. And then we took the job and we solved the problem, but we only sold it once. So now we are designing the actual products that we would like to sell in multiple copies. And that's I think, how we can actually achieve the success. So this time we are taking it completely from the, product side, and we are investing in that a lot. So that's one of the companies.
What is your approach? What is your product, Jan?
Yeah, so the products will be multiple. we are starting with the inspection product that we have already sold in one instance to a factory. And it's basically a turnkey solution for quality control. So it's the full-blown thing.
So it's not rocket science, right?
No, it's not rocket science. It's using pretty much commodified AI, and it's you can imagine this as like a gantry which sits on top of a production line. It has cameras. It's constructed from metal. It has lights, industrial grade, and then there's also networking, all interconnection, computing servers, and of course the software, which is the key ingredients that we add. The rest is pretty much commodity. But we put everything together, and we actually go through that effort of assembling everything, talking to the factory, negotiating times when they have downtime, and we can actually install all that, and we deliver it. Because the company said, okay, we don't want to have anything to do with the hardware. We basically have a problem, and we need a solution for it, and we would like to buy that. If you guys have it, please sell it to us, and we will start hammering our product with that. So that's the story. But it's not exclusively developed for them. It's our product that we also would like to sell to other factories in different industries.
So this is a basic vision approach, right?
It is computer vision. It's for quality control. The factory makes a product 24/7, and they would like to look for defects. And they had a guy watching the product 24/7, which is, I don't know if you ever watched like a conveyor belt with some material. You can last 10 minutes and then you basically don't care that much. Your attention drifts somewhere else and you want to have a smoke or a coffee and yeah.
What is your unique selling point? Because we have a lot of competitors in this market.
Yeah, that's true. I think the unique selling point is that we actually deliver this in very short time, and it doesn't have to be custom developed again. So it's ready solution, and it contains everything. Of course, there is some customization, here and there, but it's, if you would be another company which makes, like, let's say, makes steel or some fabric, and you talk to us and say, hey, I have this inspection problem. Like once a while, we have there some defect, and we send it to customers. They return. It's a lot of cost associated. Do you have something for that? And we say, yes, of course. Here it is. Here's a price tag for it. If you order it, you get it delivered in 3 months of time, and you can start using it. No worries. So we are not system integrator that would take different pieces and put them together. And also, if the customer needs an AI solution, we would ask for the AI somewhere. We are sort of like AI first company, but with a lot of experience with also that, say, mechatronics. Plus, we have a partner for making all the metal constructions and all the electricity. There's a small automation company in Czech Republic which is called Nosko. It's from Latin, actually. It means we know how, and they really know how. And it was an interesting story because, the company is an old contact which was brought to me by my father, actually. And my dad came, my dad was working for some other automation company, and they were deploying X-ray solutions there. And then he came to me and said, hey, look, they have a guy who's supervising the product 24/7. He's sitting on a chair looking through a mirror. I mean, you can do it, right? Okay, of course we can do it. That was at the time when I was at NNAISENSE. And then we had a prototype there. They really liked us. They have chosen us, they have selected us among, universities and other, I would say, big names in automation, because they really trusted us, and we had sort of like a personal relationship. And then I couldn't have worked with them for a year, and then they came back and said, like, we really want to do that. So it's a good idea to start a company just for this. But it's not just that, it's other products. So this was one. This is the inspection.
Yeah, but one more question, because many large automation companies are also offer the Siemens and Beckhoff. What is your, I would say, Jan Koutnik AI USP?
So my perception of the field is that there's a lot of companies which, let's say, 10 years ago, they had no idea what AI is, right? And they are automation companies that are trying to sort of like jump on the bandwagon. Now the bandwagon is the generative AI, so everybody is kind of adopting that. But there is still a lot of potential customers who don't need generative models, but they need very highly tuned AI, for some simpler problems. And this is what we can deliver, because we have been doing that last, let's say, 15, 20 years. Plus, so we already know the things. So as I said before, we are the AI first company, right? So we sort of know the solution to that hard part. And the rest is, and I don't want to sound bold, but the rest is kind of relatively simple, all the networks, computers, but that's sort of thought through already. But we already know how to do things which the customers cannot imagine how they could be done. And we package everything together. So that's the main advantage.
What else do you have in your portfolio?
Yeah, so then there is the thing for, this is, the first product is for inspection of the flat surfaces. Then we have the same one for inspecting the volumetric surfaces. And then we are talking to technology company in Czech, which makes very unique X-ray detectors. And they already had some applications, but they are not an integrator. And they were always looking for some who can do it. Plus, they don't know the algorithms for AI that much. They just make these chips, which are expensive already, but they are really, really good. It's like if you imagine computer tomography, but done very fast in an industrial environment. That's what they can do. They sell chips for that. So we are trying to integrate that with our AI into a product which looks like what you send your luggage at the airport through, but way faster and industrial grade. So we can actually look through the products. So this is what we are planning to do, because then we can actually see through things and we can just do the thorough inspection of the products that the factory makes. Plus the AI sort of make sure that what you actually see there, you don't have to stare at the X-ray image, at the voxel image, but AI does that.
So it's a Vision 4.0.
5.0 maybe.
Vision X, yes.
Vision, X, yes. It's marketing, but it's now we call it Inspection 3, like a 3-dimensional X.
Okay.
Yeah, the X is there actually for X-ray. You're right.
Which branches do you focus with that?
Again, it's a product for factories which make things. These so-called like factories with chimneys, which produce.
And
sorry,
you are building the model, right? You're building the model, and you will buy the sensors or the X-ray chips, right?
Yes. So we buy the X-ray chips. We have to buy we have to purchase the X-ray lamp, the source of the ionizing radiation. And we also, with our partner, we designed the whole booth because it has to be shielded and protected. And then you have to talk to the regulator in radioactive whatever. So this is complicated, but we deliver the AI. That's still our core business. But we, you can understand the company that we don't want to deliver just the AI because it's not enough. You have to give the customers the actual sort of anthropomorphic thing, right? Something that they can, like a boxed product. So this was for the inspection. Plus, we are still designing the products for the other things, the optimization. This is something we spoke about like 5 years ago. And also for the control of the factories, because the very interesting thing is that when you speak to the end customer, to the factory, about the inspection, they always say like, yeah, inspection, okay, but it's not direct cost saving for us. We also have this oven, and there is a guy who controls the oven, right? He turns one knob. And when he wants to go to a smoke, and he comes back, and he's watching some SCADA screen there, and there are 4 numbers. And if they start coming apart, he has to turn the knob, back. And if he doesn't make it in time, it costs them 100 cars of coal or something like that, which costs, 100,000 euro. So they always, through the inspection, we always uncover that they have some problem, which is maybe even easier to solve, but it actually saves them a lot of money. So that's a common story. And for that, we would like to also have the products. But the product for actual control, the actual intelligent controller, is not that easy to design. So it will still take a little bit more time before we are actually able to unveil that as well.
You mentioned the control unit, because you also offer a product, it's called Evo Control, right?
Yeah, that's it. That's what we are working on now. We are looking for the application for that. And the full story is that for having this controller deployed, you basically have to make the model of the whole industry, train the controller in using that model, and then deploy that in the industrial environments. I've also spoken with some startups in the field now, which they claim, yeah, we don't really have to work with the model, we deploy it directly. This is like what we tried to do with the Festo when we trained the controller for the hand directly on the robot, because we was just unable to make the model at the time. And they say, yeah, we have some clever algorithms, so we don't have to run as many iterations. We can actually run it with the industry. But, run it with the glass oven or run it with the robot car and destroy 100,000 cars per second. That's not really possible. So we actually have to run with some simulation. But if they say, okay, but we have really clever algorithms, that's where they invest their time. And it's going to cost them, right? So you rather build the model, which is what we know how to do now, invest time and compute into that, and then train the controller in the simulation and then deploy. Nothing has changed on that. That is what I've been pushing since, let's say, 10, 15 years ago, and it's still valid for the factories. So, and it also makes interesting conclusion for, let's say 5 years ago at the Hannover Messe, everybody was craving for Industry 4.0, and everybody wanted to have their data in the cloud, and everybody wanted to have digital twins. That was a big deal.
Today it was also the digital twins, yeah.
Yes, but now there is real need for the digital twins, because when we speak to a customer who wants to get the control deployed, they have to have the digital twin such that we can train with it and then deploy. So we actually make these models a purpose, because I remember there was a lot of companies who, let's say, had their lathes connected to the cloud and they collected a lot of data, and I asked, like, what do you do with the data? I was like, we don't know. We just have them in the cloud tower for Industry 4.0, digitalization, that's it. And I said, come on, you got to have like a bigger, idea behind it. So the idea is there, but it just needs to be utilized.
Maybe I'm wrong, but in the control scenario, please correct me if I'm wrong, a controller is trained to respond to each input with an output that brings the overall process function closer to this optimum, right?
Yes.
And how do you train that?
So this is sort of like a vague definition of a reinforcement learning problem. And you can train using various methods, right? You either frame the whole problem as supervised learning, and then you train with the normal gradient descent, or you have the controller which reads the input and sends out the output, and it has some parameters. It's always setting up the parameters correctly, such that the controller does what you want. And you can use it with the gradient. You can do it with the gradient descent, or you can do it as a black box optimization, and then you use evolutionary computation, which is what we have been doing since 20 years ago. Also, and that's very efficient also. So that's kind of easy, right? Because you don't have to worry about the complicated math behind it, and you just deploy the controller and you train it with the environment, and that's it.
What is the challenge in the moment?
Challenge there is how, because if you do the simulation of the environment such that you can train massively with that, the challenge is still how to do the simulation as fast enough such that it does not take too much time, because you don't want to wait for the results forever. And when I was at NNAISENSE, we developed a library, which is open source now. It's called EvoTorch. And that used GPUs for also simulations, and that also used the GPUs for running the algorithm. So there was basically the whole thing was running on the GPUs, was super fast. At that time, we did a simulation of the whole query and the mining trucks there, because we had the potential customer who wanted to outdo the self-driving trucks for a query. The problem is that the project never happened, because then the Russians got invaded and the query is in Ukraine, and all the drivers now drive tanks if they're not dead yet.
Okay. And can you please summarize what is the benefit for the customer with this Evo control approach?
He gets the solution faster.
Mm-hmm.
So you don't have to science the hell out of it, right? You just take the simulation of the environment, connect the controller, and run the evolutionary loop, which sets the parameters of the controller correctly. And if you have implemented it fast, then you get good results. The evolution sort of, the nice thing about evolution is that it sort of comes up with the suboptimal solution, even regardless bugs in its implementation. So it usually always works like the real evolution, like what caused us to be here. It finds its way.
Yeah, and your focus branch is industrial applications and maybe also robots.
I mean, the robot is an environment.
Okay.
For us, it always was. Also, at NNAISENSE, we when we first got the robot car, we said, yeah, it's just a robot, right? But it's not the primary focus. Now the primary focus is really on the solutions. So that's why we partner with automation companies. In an ideal case, the automation companies would be our customers, but at some point they are also our suppliers, right? Because we don't make the cameras, for example, we buy them. So it's sort of like a symbiotic thing. There are some hard problems also there, because if you want to sell some product to, let's say, automotive, it's very strictly regulated, and you have to be actually on the list of the companies of accepted solutions, and you have to have the ISO and etc. So, yeah, that's the hard part.
Yeah, and when we first talked, you also mentioned this Evo Omega approach you also have. This is a black box optimization, right? Is it the first step? Yeah.
Yeah, that's our evolutionary solution.
Okay.
But we use it, again, pretty much as we use it for two things. We use it for optimizing the controller in the last product, but we also can use it if the customer has an optimization problem. Sometimes it's difficult to figure out, even for the customer, what kind of problem they have, right? Because they say, we are sure we have a reinforcement learning problem, and it turns out they have just optimization problem, and vice versa.
Yes.
But don't take these names literally. This was just the first sketch. The website exists since like a month ago, and we were even debating how this product should be called. And it's not easy to come up with good names, but don't take it literal. It will change in the future. You will just get a bigger name.
But this is a black box optimization, right?
That's a black box optimization, yes.
And how do you proceed?
So you are asking, how it works?
Yeah.
Well, in black box optimization, there are basically two approaches. One of them is population-based. The other one is distribution-based. And distribution-based is kind of easier. So you maintain a distribution of solution, right? So you have some sort of like a solution vector, and you have a distribution around it. And then at every generation, you sample from the distribution. So you get the parameter vectors. You just get the instances. Then you evaluate them with the environment, which is the time-consuming part, right? Because, if the environment is, let's say, a simulation of a factory, or if the environment is the real robot itself, it has to perform the task. And at the end, you get some fitness score, which in reinforcement learning setup is called reward. But you get some, quantity from how good the candidate solution is. And then you rank them. And then in the distribution-based method, you update the distribution according to some clever rule. And then there are algorithms for that. In the population-based method, you actually maintain the full population. You don't sample from a distribution. And then it's a survival of the fittest. So you typically throw away the bad guys and keep the good guys. And then you, again, run another step where you, in the population-based method, you have some clever way of mixing up the genes, mixing up the solution vectors, the parametric vectors. And then again, you evaluate them and keep the better ones.
So, Jan, we have been talking about industrial AI now for 25 minutes, and genAI is not an issue at all. So, but from my point of view, I was at Hannover Messe. The industrial sector is so fascinated about genAI, but you call your approach a blue-colored AI, and I like the term. But what is blue-collar AI?
Yeah, it's I'm not coming from the American culture, right? I'm Eastern European, and we always had the words like workers and slaves,
and heavy coal mines.
And in US, these have their specific terms. White collar are the guys who wear white shirts, and they are these bankers, exactly. And intellectual sort of better paid jobs. And then you have the blue collar, blue dressed.
Yeah, they work on the shop floor.
People, and they work on the shop floor, and they do all the heavy lifting.
And we have no solutions for them.
No, we do.
At the moment.
Actually, our company does, right? So, and we are attempting to automate these jobs, right? Because as what, I traced that saying down to Joanna Maciejewska, and she said now AI can do art and writing for me, but and doesn't do, laundry and dishes, but I would rather AI to do laundry and dishes such that I can do art and writing. She's a writer, which is very, very true. And so what we want to do to make the AI for these laundry and dishes, and all that heavy lifting, such that we can do art, dancing, and why do we need a dancing robot, or why do we need a robot playing soccer? I would rather play the soccer myself and let the robot, be in the factory. So that's what we actually need. And in that sense, in my eyes, the generative models are a little bit kind of, leading it towards something slightly different to what we actually want. Of course, it's cool, right? Generating AI, it's fantastic.
And you have some approaches on the shop floor.
There's a lot of applications already, right, for language models. And it's a huge thing. And of course, if you are writing reports, if you're going to get the summaries automatically, or if you want to, let's say, do translations. My wife is a translator and interpreter, but she's basically out of a job now because there is no need for that any longer. But yes, it's sort of, I perceive it slightly as a distraction, but it's indeed cool. It solves a lot of things, and already it's been through that stage of development, science development, implementation, fast implementation, enabled by the fast machines and the clusters and so on. Lots of compute thrown at that. And we already have it in products, which is cool, but it was really, really fast. And so I think the whole industry is just trying to, again, jump on that bandwagon. A lot of the companies have that fear of missing out. They would like to get it implemented because others have it implemented also, and we would like to have a chatbot in whatever we do. That's why there's a lot of startups, and now basically if you look at the AI startup, and you uncover the stone, there is LLM under it typically.
Yeah, exactly.
Yeah, and I don't say it's bad.
No,
but it's already kind of a commodity, right?
But from your point of view now, how difficult is it now for you to realize traditional machine learning projects? Because from my point of view, the customers the C-level is fascinated by genAI, and then they go to their R&D office and say, we should do something like this. And then the R&D office says, no, we should focus on some vision inspection approaches or some optimization or Evo control approaches, but not on, genAI. So how difficult is it for a company? Yeah,
find the customers,
to find your customers, right, and to convince them not to go into genAI.
Yeah. There is still a lot of companies which are not driven by that sort of fear of not implementing the LLMs, but they still make some products and they have their own problems. So we are specifically looking for these customers, and they appear, here and there. There's still a lot of them. I think the interest is huge, and it's just a matter of looking for them properly. We are also, that's the second endeavor which I haven't mentioned, but we were lucky, and then we acquired software dealership in Czech and Slovak. It's territorial for Wolfram products. I don't know if you know the Wolfram.
Yes, sure.
Company which makes Wolfram Mathematica. And the thing is, we love the tool. So in my career, past 15 years, I have done most of the things using Mathematica, which allowed me to quickly, estimate the efforts for the products, quickly do the proof of concepts. Even at NNAISENSE, I was using it all the time.
But it's not very well known in the industrial sector.
Yes, but we would like it to be. And they are also starting that, consultancy, or they have that consultancy business established, which is not territorial. So we are able to offer consultancy solutions based on the Wolfram products. And they are getting an influx of the customers who know what they want to get solved, and they want to get it done very quickly. And these are not that much automation problems, but these are more like software solutions. But the portfolio is also huge. Plus, Wolfram has integrated their language models together with their system. And in short, it's done such that the language model takes care of what's there connected to the language, and the Wolfram part takes care of the computable aspects of it. So if you ask a question about, what's the nutrition in cubic light year of butter, it will get you the right answer. It's not. This is a standard query of a friend of mine. It doesn't come from me, but it's
why do you use it? What is so special?
It's really fast to get started, and it's really fast to get things done. And you can imagine it. It's a language. It's a computer language with a lot of built-in functions. So it's built around a different philosophy to what's being used now, which is Python. Python is cool because almost everybody's using it. And that's the advantage. The other advantage of Python is it's for free. Mathematica isn't for free. It's a commercial software, which is a huge disadvantage, obviously. But it saves time. So typically, if you start using it, let's say a third week of a month, it has already paid for itself. I started with it 15 years ago when my colleague told me, hey, why don't you just do it in Mathematica? And I have implemented all my PhD stuff, which I've done for the past 6 years in 2 weeks in Mathematica, and I'm using it since then. I'm sort of, I've indoctrinated a lot of people with that tool. But the cool thing is that it's really kind of simple. The code is very compact, and the libraries are basically for every corner of any possible science, quantum computing, neural networks. It integrates the library. The language is very neat. It's unlike Python, it's compatible with itself. You don't have different kinds of arrays. It's written by a commercial company. It's very well documented. So the documentation are sort of notebooks that you can alter and see the effects. It's very visually strong. So lots of visualizations, which are really good for impressing the people. You can use it for the teaching. What we liked to do is to create slides in it, which were interactive, right? So we came to a customer and we had a graph, this is how it looks like, this is your data. And they say, but what if we have a higher level of noise? And I said, yeah, that's easy, change the code a little bit and show them the plots for a high level of noise. And they were kind of blown away.
And how do Python and Mathematica go together at the end?
You can use it together.
Okay.
Python is, let's say if you are a scientist and you want to try some new algorithm, it may be easy in Python because somebody had already implemented that. If you want to use some standard algorithms, even like advanced machine learning and deep learning techniques, and you go with Mathematica, you have some data set. Let's say training simple LSTM is just one-liner. It fits within a tweet. So it saves time, basically. That's the main advantage.
Jan, you saw and you see a lot of industrial companies, a lot of industrial use cases. What are the 5 biggest misconceptions in the industry when it comes to AI from your point of view?
You obviously saved some questions for me, which we haven't discussed before.
Yes, that's the deal.
Yes, I got it. So the biggest one...
No, start with number 5.
The smallest one.
The smallest one, yeah. The smallest misconception. So number 5.
Yeah, then I have to figure out all 5 of them anyway. To sort them. Yes. So I'm running optimization problem in my head. My head's boiling. But I would say it comes from the fact that if a company is focused on their product, they may be misled by the news and what they read around about what AI is. Right. And then that's the company may see that the AI is a solution to all of their problems, and it's not. Right. So there's some sort of that's one. The other one is, which I already mentioned, is the distinction between reinforcement learning and optimization problems. Some companies even try to solve the optimization problem with reinforcement learning. The other misconception is that the company is embedding a sort of like a simple problem into more complex one. And then because there are tools for solving the complex one, they just unnecessarily, throw obstacles under their legs. One of the cases was rendering stock graphs and then applying visual RL to them, which does not make sense. The other case was some graph of some network and optimizing the traffic in it and using reinforcement learning for games, which was based on vision also. So taking simple graph and embedding it into, high resolution image would not help you. So that was the second one.
That was number 4. Now number 3.
Number 3 might be, and I've also seen that, there's a company who wants to get some AI achieved, and they say, okay, so instead of, hiring you guys, we can hire 3 PhD students who would solve it. and they don't, right? Because they would like to do their PhD and do the research, but they don't create the finished product such that the company can use that. I've seen it so many times, and then the company came to us again and said, like, yeah, our guys didn't do well, and then we would like your help. And then we said, yes, but our markup's going to be like 2 times higher.
That's the third one. Now the second.
Now the second one is the estimation of how big the thing is. And sometimes the problem seems to be small, but it wraps in like the full-blown, solution which has a lot of aspects. And we already see it in our products. The AI in our product is a tiny piece of that. And the rest of it is just the negotiations with the factory when they can go there. Then there's some security guy who says, no, we wouldn't connect you to this network. How about we connect to the Wi-Fi? No way. All USB ports have to be filled with Dentacril and you cannot connect any stuff like that, right? So there is always like a lot of things around. And I can even say that like solving the principal issue which is there is, for me, it's always has been like a bathroom project. Like I take a laptop to the toilet and before I'm done with the solution. But yeah, so that's like a misestimation of, how big the thing is. And that's why we don't have the AI done yet. We don't have everything automated, what could be automated.
And the number one?
Number one is that the generative models are the AI. When I was an AI kid, I was at the university. I had a dream about that eventually I'll have a machine on my desktop and we will implement some sort of approach to general AI, and it will have a microphone and a reproductor, and as we speak, it listens, and eventually it will start mumbling, and then eventually it will start, asking questions, and we would answer, and that's how we train our own little AI, like we saw it in the Space Odyssey. Right now, with large language models, we are sort of on the path to that, and this may be done. So I'm happy. I don't have to do my ChatGPT, and I didn't have to invest in that. And there are other teams which have focused on it. It's actually a pretty cool thing. So I'm quite happy. But it's not the general AI yet. It does not solve all the problems, and it's what we started with. It doesn't get its hands dirty that much. It can control a robot, maybe, right? Maybe we will see applications of the generative models in reinforcement learning. That's gonna be the big deal when it gets actuators, right? And I had a colleague who always claimed that we have to have the actuators. His name is Bas Steunebring. He was a big push for general AI. But, it does not solve all the problems. And I think we need a complementary solutions to the problems which could not be solved by generating texts and generating images. That's why, I call it the blue collar AI. And there is a fear inside me that, it's going to be like a little bit of a, how's it called when you drink one night and then next morning you have the thing, I forgot the English term for it, hangover.
AI hangover?
Yeah, there might be an AI hangover coming. Then when the actual decision makers in the company will figure out, yeah, but the LLMs, they wouldn't solve all our problems. What are we going to do? People promised us that we're going to have finally the AI solving all our problems, but it's not. And that may cause the AI winter, right? People will turn their backs to it and they'll say, yeah, but it's just, this is not what we were promised, but they were not promised anything.
Which technologies do you see developing positively for the industrial sector? Is it reinforcement learning overrated, overhyped? How will reinforcement learning develop?
It's not overrated. It's the grand problem that industries are pursuing, and that it's a grand problem that they may have, right? Although they may start with the easier problems. It's not, I wouldn't say it's overrated. I think it's been sidetracked a little bit right now with generative models, with the whole generative AI. But it deserves its own wave. And I think it's a problem which is represented by the industry, right? Because if there is a company which makes something, cars, or if they basically are trying to maximize their future expected revenue through doing something, they indeed live through a definition of a reinforcement learning problem, and we aim to solve this.
Jan, can you give us one more example, one more concrete use case you're working on in the moment?
Yeah, so it's a solution which is for another automation company which makes production lines, and they have a problem that they have a production line which they constructed, and they have a painting booth somewhere, and they would like to paint the hanging metal pieces. Like imagine like it's an automotive where they hang the wheel and the wishbone and stuff like that, and they'd like to get it painted. They have a painting robot. It's a wet paint, and the robot needs to know where to paint. But the workers, they hang the pieces in sort of like a random order and not in precise locations. And if they paint everywhere, it would be a waste of paint. So they ask us, like, we need that missing component. But the robotic company, they deliver robots, they deliver the painting nozzles, everything, but they don't have that part. And how do we do this? Okay, how about we put the camera there and we take the image and we tell you where these pieces are, we localize them. And he said, yeah, but we would have to deploy it and then collect the data. And then it will take some time training. The guy already knows a little bit about AI. He's going, no, come on, you just upload the CAD data. We will train in simulation and we deploy it. We shorten the whole period of deployment. At the time when we install the camera and lights, when we turn it on, the system is going to be already working.
And how accurate was that from the CAD data to the real world?
It's nearly perfect. It needs a little bit of adjustment because you never know like what the lighting's going to be like, and sometimes there are slight discrepancies between the renders and the reality. But noise is our friend always in that in that case, and we've done it many times. So we are confident that as the time comes and the customer orders this, we would be able to deliver that. It just needs to give us the CAD data up front. That's all.
Once again, I want to talk a little bit about data. Is data the big problem for the industrial sector? What is your opinion?
It was, I would say. It was in business, it was always hard to dig the data out from the customer. So the customer typically tells you, yeah, we have lots of data.
Don't want to share.
We can collect it. And that's the worst saying. Like if they say we can collect it, it means that they don't have it and they could not do it quickly. But no, I'm just making fun of it, but that's my experience. But typically customers can have a lot of data. And then it's, of course, problem technically, how to even get it. Somebody has like 100 hard drives, 8 terabyte of data each, and then you got to get sense out of it. Sometimes they have a problem which does not require that. These are interesting cases because when you can generate the data on the fly, especially with the RL, right? That's what you do. It's not that terrible. There is the whole field, data science, which you have discussed quite a bit also. And it was a big deal 5 years ago in the Industry 4.0 and digitalization of all the industries and how to get most of the data. But the key thing is to use the data, right? Just make sense out of it, explain it properly, record only what you would need eventually. Of course, you can record everything, but there's no point in many cases. So, yeah, but it's a problem. Sometimes it's a problem to get the data from the customer, the reasonable data. Let's say with our deployment for the defectoscopy now, the customer, it was interesting. We were there negotiating the deal, and they said how many, because they have defects, and we need these pre-classified by their experts, such that we can train the system from it. And we ask, how many data you have? It's, okay, how much do you need? And I said something like, like 10,000 samples, and they said, that's what your competition said. And my colleagues then said, no. We just work with how many data you have. If you have 100, we can work with 100. We'll just make it a little bit smarter, and then we will make tricks to such that we are okay with a small amount of data. So typically, we work with as many data as the customers has. We don't push them, and in some cases it would be even unreasonable just to push them to collect data set which is unreasonable. We just work with what they have.
And do you use synthetic data too, right?
We do that, yes. There are even startups which do it. I know at least 2 of them in Germany which have started their platform on synthetic data, and they basically don't do much of AI for perception, basically, but they use it for generating data sets.
What is your opinion on that?
I think it's a good idea. Whatever you can do in simulation, do it in simulation, so you don't have to waste real resources. And the real stuff is pain. It's fun to play with lights, cameras, but at the same time, it's a lot of work. And it's, if you can get away with simulating everything, do it. It's cheaper and faster.
What are your next steps, Jan, with your company?
Yeah, now the heavy lifting comes, more marketing. We'd like to get the customers all around Europe, basically. We start there. Now we only have customers in Czech. So we'd like to expand.
You're looking for partners, automation companies, or?
Yes, also. Although we have, as I said before, we have a good partner. But we would like to get our solution to become a standard component that the automation companies can embed in their production lines. So I'm looking for partners in automation also. The target customers and the automation companies.
Jan, it was a pleasure. We wish you all the best. And it was a very interesting discussion, and greetings to Lugano.
Yeah, thanks to having me. It's been my pleasure, and I appreciate. I know that I didn't let you talk much, but
That's the deal. Yeah, you have to answer. Jan, thanks a lot. Bye-bye.
Okay, have a nice day, and talk to you soon. Thanks.
Bye-bye.